Section 5.3, Writing Chemical Equations. Before we write chemical equations, let's take a look at a chemical reaction. This is called the thermite reaction, figure 5.9. The powder form of gray aluminum metal and red iron 3 oxide are mixed and poured into a ceramic container right here, with a small hole in the bottom. A wick in the pile of powder is lit. The powder smokes and then there are sudden sparks. The molten iron actually runs through the hole, and aluminum oxide is what is left after the reaction. This reaction is used to weld iron or steel together. Now that was a long-winded explanation. Let's take it to paper and see if we can make a symbolic representation of this reaction. Here's the word equation for the thermite reaction. Chemists use symbolic representations called chemical equations. Here's the chemical equation. We have our reactants, they will react and they will produce our products. For this reaction to take place, we must have heat. A few other things you should notice about this equation. We have an S, S, and L. Those are for the states of matter. If it is a solid in the equation, you should have a subscript of S. For a liquid, you should have a subscript of L. Gas should be G, and aqueous should be A, Q. Also in a chemical equation, there is conservation of matter, meaning that matter cannot be created or destroyed. So the amount of matter on this side must be the same amount as the matter on this side. So there must be the same amount of aluminum on this side as there are aluminum on this side. So looking at this equation right now, is conservation of matter being kept? No, it is not. We have one aluminum and we have two aluminum here. So our next step in writing chemical equations is balancing the equation. I like to use a tally system when I am balancing equations. Let me show you. I have aluminum on this side and aluminum on this side. I have iron on this side, I have iron on this side, and I have oxygen. Let's count how many aluminum I have on my reactant side. I have 1. Iron, I have 2. Oxygen, 3. Now let's talk about the product side. I have 2 aluminum, I have 3 oxygen, and I have 1 iron. Now let's compare these. If I have 1 aluminum over here and 2 over here, I know I have to have 2 aluminum over here. So let me put a 2 out front. So that changes the amount of aluminum. Now my aluminum balance. What about my irons? My irons do not balance. So let's take a look at my iron. Oh look, I've got iron right here. Let's put a 2 there. Am I balanced? 2 aluminum, 2 aluminum, 2 iron, 2 iron, 3 oxygen, 3 oxygen. I am balanced. This is my balanced equation. In a chemical equation, conservation of matter must exist. So looking at this equation, is conservation of matter occurring? Let's take a look. I've covered up our equation with little pieces of paper representing the actual elements and atoms. So here I've got oxygen, it's a diatomic, so there are 2 atoms. Here I have the diatomic hydrogen, and here I'm producing water, H2O, 2 hydrogens, 1 oxygen. So we must have the same amount of oxygen on this side as we do on this side. I must have conservation of matter. So I must have 2 oxygen on this side. There must be 2 water molecules. Now let's count the hydrogen. 1, 2, 3, 4. And only 2 on this side. There is my balanced equation. Let's do the same exercise we just completed with paper, but now we must do it with paper and pencil. On this side, I have oxygen and I have hydrogen. I also have oxygen and hydrogen on this side. So let's count how many oxygen I have on this side. I have 2. Hydrogen, I have 2. Over here, I have 1 oxygen and 2 hydrogen. Here's my problem. I must have 2 oxygen, so I put a 2 out in front. That changes this to a 2, but it also changes the amount of hydrogens I have. I now have 4 hydrogen. Let's compare hydrogens now. That means I must put a 2 in front here. So this turns into a 4 also. I'm balanced. Let's do another. I've got carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. Over here I have 1 carbon, 4 hydrogen, 2 oxygen. And over here I have 1 carbon, 2 hydrogen, and 3 oxygen. Let's compare these. The carbons match. What about the hydrogen and what about the oxygen? Well, let's first take care of the hydrogen. I need 4 hydrogen so I can match the 4 here. Let's put a 2 there, and that will bring that up to 4, right? 2 times 2 is 4. But that also changes how many oxygen I have. So now I have 2 oxygen here and 2 oxygen here for a total of 4. Comparing the oxygens, oh look, there's my oxygen right there. If I put a 2 there, that will bring me up to 4. This one is a little bit trickier because we have to deal with fractions, but let's start out like we normally would. I first write the elements I'm dealing with, carbon, hydrogen, and oxygen, on both the reactant and the product side. Now I need to count them up. I've counted them up, and this is what I have. Now I need to start balancing. Where should I start? Let's start with the carbon. I have 4 carbon here, and I know the only spot I have carbon over here is in this location. So let's put a 4 out front. That changes this to 4, but it also changes my oxygen. 4 times 2 is 8, plus 1 is 9. Well, right now this looks like a mess, but let's keep going. I know that my oxygen is alone over here. It's not attached to anything, so I'm going to balance my oxygen at the very end. So let's next take a look at hydrogen. I have 10 hydrogen on my reactant side and 2 on this side. That means we can put a 5 right there, and that will give me 10 hydrogen, but that will also give me how many oxygen? 5 oxygen here and 8 oxygen there. I have a total of 13 oxygen. I know 2 goes into 13 6.5 times. So I'm going to put 6.5 right there. That would change this to 13. But can I have half of an element or half of an atom? No. But what I can do is I can multiply this entire equation by a value of 2. Here's our final equation. What about balancing an equation with an unchanged oxoanion, or also we know them as polyatomics? We can actually group them together when we do the tally system. So let me write those up. We have copper, chlorine, silver, and nitrate. We also have those on the product side. Now we need to count them up from our equation. This is my final equation.